Most of you, I think, already know me. So I'm Emil, right? I'm running a cryopreservation organization. I think mostly this is supposed to be like a bit of a Q&A. So I have also some slides to show what we've been up to. Once the slides are available. So basically, I'm running two organizations. One is a non-profit research organization based in Switzerland that does long-term storage for cryopreservation and does anything from fundamental to applied research, right? And then one operative organization called Tomorrow Bio, which is a cryopreservation provider for Europe. And so basically we run multiple medical teams over Europe to do cryopreservations if anybody of our members or anybody else wants to be cryopreserved. And then the foundation runs a research institute that does from storage to research everything that needs to be done to make cryopreservation work in the long run. And of course, the fundamental logic, and this is kind of why I'm also on this longevity track, I guess, is because I very much hope that longevity will work at some point, right? Meaning that people can live significantly longer than currently possible. So mostly my personal motivation is mostly maximum lifespan, while of course maintaining health as well. But of course, we're at a time where this might not be possible anytime soon yet. And to kind of do it as a bit of a Q&A, right, I'll show you. I briefly introduced myself, right? Wait. What is that? So I briefly introduced myself, right? So by training, I'm a doctor, then did cancer research for my first part of the career, then run a few tech companies. Totally had nothing to do with longevity back in the day. I didn't know what to do, so I basically ran them to then wait my time until I actually felt like there's something that has high impact to make it possible to live longer. And since I didn't find out anything in the traditional longevity space, I decided for cryopreservation. And now I'm running these two organizations that are already introduced Tomorrow Bio, based in Berlin in Germany, and the European Biostasis Foundation in Switzerland, right? And now these slides are not primarily for this talk, so they're a bit more introductory. Right? What is cryopreservation? Just for someone who might not know yet, right? It basically uses extreme low temperatures and cryoprotective agents to make sure that you can cool a body, an organism down to cryogenic temperatures, which is somewhere around negative 196 in most cases, but can also be negative 140. Actually 140, if you want to dig into detail later, is better from a quality standpoint. And then you keep this organism, you keep the temperature for, well, as long as you kind of need to, until in the future, hopefully at some point, the underlying disease, the underlying condition that killed the person is curable. And at the same time, and this is probably the more important point, it is as possible to, of course, survive someone, right? It's not about freezing. You can do it for cells currently, right? You can do it for organs, for some at least. You can do it for some organisms. You cannot do it yet for humans. You can cryopreserve a human, but you cannot bring them back, right? And of course, I already mentioned it. The main problem here is, or the main reason why I would argue that it makes sense to put money and time and resources into cryopreservation is because a lot of people will very likely die much before any other maximum life extending technology will be around. And so cryopreservation might give you a chance, right? So again, these are a bit introductory talks. Of course, we always deal with these kinds of images when we give any journalist, give any interviews, right? Very important, nothing here gets frozen, at least in a good case. In an average case, unfortunately, there is still a good amount of ice formation. A lot what we do is to reduce that ice formation. But of course, every newspaper always has the headline, these are the guys who freeze humans, these kinds of images, and so on. But that's kind of part of the game if you do any PR stuff. The articles themselves are usually very fair, right? So in the past, cryopreservation had a bit of or even a good amount of a bad reputation to a degree, right? This has luckily, at least in most areas, has gotten significantly better, where, well, we deal with a bit of annoying headlines, but the articles themselves are pretty fair and fine, right? It's very important, of course, that if you want to sign up people, that informed consent is very, very important. A key for cryopreservation, making sure that people understand that this is a technology that might work, right? Probably higher probability, or definitely higher probability than being cremated or being buried. But then again, no one can say when, and technically also if it will ever work. So this is the Research Institute that I've built, and of course I can show more pictures of it. It's basically it's a bit north of Zurich in Switzerland, of the Zurich airport, right? It had large underground storage. So back here underground, there's you can't see it. It's actually in the back of the building, where you have large storage doors, like 3.20 meters high storage doors for whole body patients. All underground, and then it has also a very traditional lab space, office space for the researchers, imaging facility with CT scanner, operation room, and so on, to basically do the whole procedure from A to Z, including the research, including the quality assurance in that facility. As I said, we have multiple medical teams. This is our Berlin team, right? We have one in Berlin. We have a partnership team in Amsterdam. We have one team that we're currently building in Zurich. And now we're starting to build teams in Miami, in southern Florida, Miami and the surrounding area, in New York, and in the Bay Area, to cover those regions as well. New York and southern Florida, together with the US partner organization, and Bay Area, we will cover with our own team, to then also expand into the US. We're running an annual conference to kind of advance the science and bring the community together. That will be in October, or is always in October in Zurich, 20 to 22nd next year. Always a very nice conference kind of for research collaborations and getting the word out. And now we're starting to build a new organizations. Of course, here there's a good amount of crypto people always. So we're launching CryoDAO, similar to VitaDAO, also together with a couple of the VitaDAO people like Vincent and Lawrence and so on are involved to fund basic science research, anything that is basically very difficult to fund currently in cryopreservation research. We fund with this CryoDAO. Currently 2 projects probably that we will fund. One is kind of in combination medication, and the other one is novel rewarming techniques with ultrasound transducers at a lab in Spain. So if anybody's interested, follow us, CryoDAO, or reach out to us if this is a topic that you're interested in. Right, if anybody wants to reach out, of course, well, again, most of you already know me, and otherwise, I'm more than happy to answer any questions that you might have. Right? And of course, also all the critical questions that there might be.
Very cool.
Thank you.
When you showed a picture of the facility,
yeah.
Is there a reason you can't show the inside?
No, there's no reason.
Okay. It's probably better to show like the inside in the future. If you can swap that out.
Yeah. The inside, the problem is like a cryopreservation facility, it looks like a room.
I guess so.
What is there? There is not anything that is super exciting inside, right? I mean, there are a couple of maybe. Well, I don't know if this has any type of sharing, because of course I have a lot of pictures from the inside. It's basically it looks like an operation room, right? It has a large operation room inside. Right. It has a very standard-looking lab, nice-looking lab. It's still standard, right? And then it has a very large underground room with pretty high ceilings for long-term storage.
Okay.
But there isn't anything, super unique to the building. Yeah.
Where is everyone?
That is a really
in
good
Berlin,
question.
what's the Berlin operation?
So the Berlin operations is basically it's a standby team, like a medical team, right? Doctors, perfusionists, and so on. And then secondarily, it's an office, right? Because there are kind of 2 things that you need to do for cryopreservation, right? As long as if there are not more people interested 10 years from now in the topic of cryopreservation, then cryopreservation at some point it will not be a thing, right? Because currently 5,000 people worldwide have cryopreservation companies, right? Yeah. If it's like 7,000 in 10 years, then who's going to fund research for something that 7,000 people are interested in, right? Then it will always stay a super small field. But if it's possible, or if we're able to bring it down to 10,000, or at some point 100,000, or some point 1 million people interested in it, right? Then at some point, and this is why we're running these two organizations, the goal is to at some point have 100,000 or 200,000 or 3 or whatever 100,000 people sign up, and then they pay monthly membership fees. And since everything in cryopreservation is relatively affordable, or scales well, right? Then you can use that money to fund research, right? Because that's kind of the plan. You have a lot of members who signed up, right? And then you fund research from cash flow. But of course, that only works if you get to these numbers. So that's kind of our job number 1. And then job number 2 is, until such time, just raise basically money from philanthropical donors to fund research. Because of course, there's a lot of research that needs to be done.
How much effort are you putting into vitrifying human organs? Just the organs?
Close to none. I mean, all of our research goes towards brain preservation, right?
Okay.
So the reason is, so if you run an organization, it's not like a thousands of employees, right? And we have like 20, right? So it's extremely important to keep laser focused, right?
Right.
Organ preservation, there is overlap, right? I'm not saying this would be research that wouldn't help us at all, right? But it's not exactly the same. And more importantly, there's a lot of regulation that you would need to do for organ preservation, right?
Oh.
Like clinical trials and so on and so on.
I see.
Which is all something where I'm very much focused on not diluting the mission of the organization, right?
Right.
Because organizations have a very hard time staying on topic, especially if the other thing that you would do, for example, organ preservation, has bigger market, right? More financially viable.
Right.
And suddenly all your employees are always like, hey, should we not do more of that, right? Because then my shares are worth more, right? So that's why we're not doing organ preservation. That's why we're not doing cell preservation, right?
Okay.
We do human preservation, and as an extension, brain preservation. In fact, we do now also offer brain-only preservation to make it possible to offer it more affordably, right? Whole body cryopreservation has a price tag of 200,000 euros, right? So very, very expensive. For brain preservation, you can offer it at like 50, right?
You mean head preservation?
No, brain.
You're actually stripping the brain, just bring out the brain from the head. How are you doing that with still feeling that you're not actually damaging it in the process of doing that? I think the major objection to neuropreservation actually being neuro rather than head was that getting it out was not a small undertaking.
It is not a small undertaking, but it's also not. So the problem is the standard brain removal process is a so-called anterior process, right? You basically cut open here, and then you cut around, and then you kind of twist the brain out, and then you cut the cranial nerves, right? But if you do a so-called anterior-posterior approach, right, where you also open the back, then you have significantly more access and can kind of take it out without any. There's no contortions or anything like that.
So if that method's so much better, why weren't people doing that at the start?
Start of what?
Taking brains out of heads.
Because it's way more work. And normally you don't need, like everybody who takes brains out of heads normally doesn't care that much, right?
That's true.
So I mean, if a funeral home does it, if a pathologist does it, right, the damage that you would generate during it, it's not crazy, but it's not.
Interesting.
And it's a more complex procedure, right? Because you need to turn the body around. You have more surgical. You have an additional surgical step where you need to open more of the skull needs to be opened and so on.
I'd actually like to see a presentation just on that.
Yeah.
Someday.
Yeah.
That's actually kind of interesting.
No, absolutely. Like this is not probably a presentation for a smaller for an in-depth crowd, right?
Yeah, next Cryonics conference.
Yeah. And by the way, what I'm saying is it's not something we do today, right? This is something we're currently working on doing. Because like one of the biggest pet peeves for cryopreservation I currently have is that it's just prohibitively expensive to some people, right?
Yeah.
You can't. It's not affordable.
Right.
Yeah.
What is the advantage of removing the brain other than just keeping the head?
It's mostly two reasons, right? So if you just take the brain, you can do it even cheaper, right? Because you have less volume to store. right, in your doers, right?
Oh, nice.
Huh? Oh, but it's actually a good amount, right? It's double. So. Huh?
Half of the skull is the brain, I guess, volume-wise.
No. The brain is significantly smaller. If in cryo, it goes down in size a bit, right? So like head is actually, I'm not sure. I need to look it up. It's 2 or 3x.
Oh, wow.
And the other reason is brain biobanking, very much accepted. No one is complaining about brain biobanking. Having heads in your facility, every legal problem, not every, most legal problems in the past for cryopreservation at US organizations stem from neurons, like from heads, right? Because the family basically, there have been cases where they took off the head and then sent the rest of the body back. Okay, unforced error, like probably wasn't the greatest idea ever, but
Again, you kind of have to do that, unfortunately, under the present situation, unless there's further sort of finessing. You're either going to send them the body back, or you're going to upfront have a very detailed discussion about,
Yes.
hey, we're sending you the body back. Either of which probably comes to the same place.
yeah. So
So it's not scientific reasons, basically.
no, it's not. Well, no. So there's one scientific reason in certain cases. So if you have a body with high amount of ischemia, right, then you wanna move away probably, and all of what I'm saying now is kind of early stages of research, right? You want to probably move away from perfusion. You want to go into immersion, and then if you go into immersion, you want to probably do immersion fixation. Plus, you want to probably cannulate the ventricles, right? So that you can do immersion from the outside and from the inside, and you still do perfusion additionally to make sure, because if you have a lot of ischemia, the cryoprotective agent, since it's a highly viscous solution, right, it's not going to go into all of the brain anyway, right? So the main problem is you do perfusion, then you cool down, then you do a CT scan, and you see, oh, well, ice formation everywhere. And now, of course, the big question is, do you really rather want to, at what kind of percentage of ice formation would you rather switch over to then fixation, where, of course, everything would be now cross-linked, and that brings some potential problems in the future for revival. But probably it's better than having a lot of ice formation, right? This now becomes a bit difficult to argue, of course. But I would probably say it's probably better to be fixed than to have a lot of ice formation, at least probably. And of course, if you take the brain out, then you can do immersion fixation, whereas in the head it's very difficult to do.
And the time factor, how long does it take for you to remove the brain before you can start perfusing?
Yeah, so start perfusing. So perfusing you can start without taking the head out, right?
So you start perfusing and then you take the brain out?
So yes, so in our standard procedure, right, is aortic cannulation. So we do median stenotomy, right? Now, if you have a lot of ischemia, you will probably not reach every part of the brain, right? But you would already start not necessarily to now get cryoprotective agent in, but to use the cooled cryoprotective agent at a low concentrations, where it's not that viscous yet, as a coolant. Right, so you would still cool down. So basically, you would reduce warm and like basically ischemic time. Right, now you have time in quotation marks. Right, at 4 degrees, you can do the operation in hours. It doesn't really matter much anymore. Right, not days but hours. Then you start taking the brain out. Right, and then you would move directly to immersion fixation. And everything I'm saying, again, like what are the cutoffs here? Do you want to do that after 5 hours, after 12, after 3? Open research topics. Very difficult to say. No one knows yet. But probably you don't want to, probably attempting perfusion in highly ischemic cases is probably a bad idea. And it's probably not sufficient. Or you say, hey, ice formation is better than cross-linking, which of course is quite difficult. I don't think there's going to be an answer to that anytime soon.
So there's a concept called persuflation, which I heard of recently. Do
Yeah.
you know what that is? Can you explain it?
Yeah, so sure. So persuflation. So persuflation basically is a method where you use the circulatory system and you circulate cooled gas through the circulatory system, right? It used to be a hot topic, has now become a hot topic again, right? There's a company in the US called Arigos Technologies, Stephen Sickles and Tanya Jones's company. In the past, they prototype persiflation for organs, mostly hearts. They might have had some good results, but it wasn't really published that much. And then the company went out of business, unfortunately, and Stefan Sickle died. And now with Aubrey getting kind of involved in that topic again, and other people, like somehow this has become a hot topic again. It might be super interesting, but I think it's not fully proven yet if this is the crazy impact that it might have, right? Yeah. But it's a cool technology, so it should definitely be researched, right? It's interesting, but I think not yet proven to a full level. Yeah.
All right. Do we have any other questions for Cryonics?
Yeah, please.
So the timeline, what timeline do you imagine based on the
Timeline until revival or timeline for doing a cryopreservation?
Oh.
All right, so for doing a cryopreservation, right, so you want to basically stop as quick or start as shortly after circulatory arrest, right? So heart stops beating, body is not supplied with oxygen anymore. Now cells start dying, right? Now you want to cool down to stop that dying process, right? Legally speaking, you need to wait. You can't, like, circulatory arrest is not enough. Legally speaking, you need to wait until the person is pronounced. Different countries have different rules of when is pronouncement possible, right? In some cases, it's basically when the heart stops, pronouncement is possible, for example, in the US. Once that happens, you now start cooling down, right? And once you've reached somewhere between 20 to 28 degrees core temperature, at that point, you start with perfusion, right? Putting the cryoprotective agent in. Then over many hours, not many, but let's say 4 hours, you put the cryoprotective agent in. Once the cryoprotective agent is in, you can cool down to around negative 120 degrees. And now from 120 degrees to your final storage temperature, you want to cool over around 100 hours. And the reason for that is basically if you cool too fast, you get thermal stress, and you want to reduce thermal stress as much as possible. Okay, now at that temperature, you can keep the body for however long you want to. For revival, no one knows. It's not going to be 20 years. It's not going to be 30 years, probably. So whenever I'm being asked that, right, I give the cop-out answer. It's at some point when all predictions basically break apart. So maybe 50 years, maybe 100 years, right? But for me, I don't think there's a meaningful difference between saying 50 or 100 or 200 years, right? This is such a blur that making any prediction, I don't think you can really state that you can make a better prediction 100 years in the future than 200 years in the future. I feel like it's all blurry. I would argue it's probably not 10,000 years. But everything else, I don't think anybody can say. And of course, it very much also depends on how much funding will be available for research, right? At current funding rates, it's going to be closer to 1,000. Hopefully, when I'm done and when I'm getting into cryopreservation, at that point, there's enough funding to make it, let's say, 50 or so. But it's going to be a long time. Yeah.
All right. Well, thanks for giving your
Sure.
talk.
Thank you.